So here we will continue the previous lecture, and we were discussing about the various models. So one of the important model was Tansel's model. So Tansel introduced this model in '86, and it supports the concept of historical relations, adds both valid time and different structure types on attributes such as atomic, set valued, triplets, and set triplet valued attributes. So introduced totally a new concept, which was not introduced by anyone else. So he introduced the concept of various new types of attributes. The first contain the atomic values only. The second is a set of atomic values, means we may have various values, but you can have a set. It means that it can include multiple members. The last two are attributes with timestamps. Which one? The last two? We're talking about triplets and set triplet valued attributes. That is, each triplet is an attribute value with valid start and end times. Atomic attributes contain values such as integers, real values, and character strings. So we can have those atomic values. And when I say an atomic value, atomic attribute, it cannot be further divided. So it represents a single value. So triplet valued attribute consists of valid time interval, which is closed at the lower and open at the upper bound, as you can see in this point. It means when it is open at the upper bound, it means the values may be added together with an atomic value. Given value, that value will be assigned to it. You can see in this slide that you have the triplet value attribute, and that is associated a particular value. The temporal data model presented in '85 and '86 supports historical relations. So it also supports the historical relations, and whenever we manage the historical relation, it means that we are considering the valid time dimension. Tansel model based on, yes, now it is based on a very different approach that is called attribute value timestamping. So we talked about a lot about tuple timestamping approach. What is attribute timestamping approach? The attribute timestamping approach deals with in a relation in a way that we coupled the temporal attribute with the attribute value rather than with a record or a tuple. So when we coupled it with the attribute value, there is a violation of first normal form assumption, because when we coupled it with the attribute value, so it might have more than one values. So if it has more than one values, then sometimes it is difficult to handle in a classical model. So we have to introduce some new concepts, or you can say we have to introduce some sort of an extension into the model to handle that particular data. The model suggests to use both atomic and triplet attributes for keys where values are not expected to change over time. So when we have to manage such values in a relation, we have to manage the key as well, because as you know that the key is responsible for identifying all the tuples, and that provides an identity to the tuples. So that has to be different. So if you use both the atomic and triplet attributes for keys, then we can handle it when the time is changing in the Tansel's model. And you can see the Tansel model example, that in this example you can see that there are two attributes which are being used. Okay, and there is another thing you can see in this relation, that does not follow homogeneity. In the previous model, in the HRM model, that follows the homogeneity principle. It means the lifespan is same, but here you cannot see the lifespan is same. So here you can see that the various attributes. There are two attributes, which is salary and department, are being chosen as the temporal attributes, and you can see that a particular value is associated, for example, a 15K that is associated in this particular interval, that is January 2001 to February 2004. And there is another value that is from February 2004 and to now. Now is sort of an attribute which represents the current date, or up till now, you can say. So now is sort of an operator which we use in the query languages as well, because it is not possible. It is difficult to add values for every time when we make the queries. So rather than this, when a fact is true, starting from a particular date, we use now. So in the second portion, you can see that the value of the salary is changed, but both these two values are represented in a set. Now that is the set. We have, you can see the curly brackets. So you have that various values which are being recorded over here. It may be increased further. We may have new values. But what is the advantage of having this model is that all those changes in a particular attribute are being represented in the same tuple. If I do the same thing in the tuple timestamping approach, I might have that Asim many times in a relation. So if the changes are so rapid, so sometimes that generates the voluminous data, which is not required. So in this manner, as far as the design is concerned, attribute timestamping approach is much better than the tuple timestamping approach. But as far as implementation is concerned, there are some drawbacks in the attribute timestamping approach because the classical relation model does not support it. When I say the classical relation model does not support it, it means that whatever the query language which you are using basically does not support this kind of data or this kind of representation for the operation. So we have to modify a lot of things such that to implement this model. But as far as design is concerned, that is much simple design, and you can see the same entity asks him, and you have all those values. For example, his values may be changing in the department as well. Let's suppose salary is changing at the same time he is moved from audit to finance, or he is moved from finance to accounts. So all those values will be recorded in a set. So it forms a set. So that is the representation of a Tansel's model. And now we will move to the next model, that is called McKenzie model. McKenzie introduced various models if you go into the literature, and he has a lot of contributions as far as the temporal databases is concerned. So McKenzie model is basically and also an attribute value timestamping model, as we have discussed in the previous model. McKenzie also support the one thing which I want to share over here is that we are not bound to use tuple timestamping, or we are not bound to use attribute timestamping. Actually, it is up to the problem, whatever we have, how we design it. So, and not necessarily that all the solutions are available in the relation model. We have other approaches as well. For example, we might use the object-oriented data modeling approach rather than relation model approach, because in the object-oriented data modeling approach, we have the concept of a class. So in a class definition, the concept of, like, for example, time can be managed in a much better way as compared to the relation model. So it is up to us that which modeling approach we want to apply, and which model we want to apply. But whenever we are thinking about solving a particular problem or proposing a model, we must understand that what are the pros and cons of applying that particular model. So there are various approaches. So it is up to us which approach best suits to our problem. I cannot say that I outrightly reject one model or the other model, but it opens your mind that there are various ways by which we can handle the data, and we might come out with new models as well. We might come out with new approaches, and still the new models and approaches are being proposed if you go into the literature, and I will discuss this in the next session. So in this McKenzie model is represented as a sequence of valid time states indexed by transaction time. So he gave a representation in terms of a sequence of valid time states. Yeah. See, when I say a sequence of valid time state, it means the sequence means the first valid time state, and the next valid time state, and the next valid time states, so on and so forth. That is represent the sequence, and that sequence is indexed by a transaction time. So indexing is being done by using transaction time. The timestamps associated with each attribute values are sets of valid time chronon. And you know what is a chronon if I recall you, because I have discussed the concept of a chronon with you in the previous lecture. I just want to see. Okay, chronon. A time can be mapped into an underlying time axis. The time axis can be viewed as a set of time points. The smallest non-decomposable time unit on the time axis is called a chronon. For example, you want to define a salary. The salary of an individual, there is no need to define it on a second basis. There is no need to define it on a minute basis. Sometimes there is no need to define it on the hour basis, maybe, or it can be hour, but it means that whatever the problem you have and you are modeling it, how you want to do it. So it's up to you. So you always define chronons, because we have to manage time in the model, and as we know that time is continuous in nature. So but whenever talk about databases, we handle those databases by converting that continuous time into the discrete time. So here the timestamp as well, each attribute values are sets of valid time chronon, whatever the chronons you have defined, but valid time chronons. In the McKenzie model, a temporal database is a finite sequence which is represented as db0, comma, db1, comma, db2, comma, dash, 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 ddbn, where each element, whatever the element is, ddbi of the sequence, is a state relative to a particular transaction time. So every state is relative to a particular transaction time. So McKenzie extends the relational algebra. McKenzie extends the relational algebra extend the relational extend the relation algebra to support both temporal dimensions. So he uses again the algebraic approach. The relational algebra means operators. What are those operators? We are talking about joins. We are talking about inner joins, outer joins. We are talking about the cross transaction time, and then we will move on. We will have the temporal valid time, temporal transaction time. McKenzie proposed a historical algebra also, because whenever we deal with the operators, we have to come out with the algebra. Algebra means operations. So we have to define all those operations which are related to it. In the classical relation models, we have the limited operations. So whenever we move towards the temporal dimensions, we have new operators as well. For example, we are dealing with temporal join, which is not defined in the classical relational algebra. So here he proposed the complete algebra as well, that how his model works, how tables will be manipulated, how the data will be retrieved from the data from the database, and how it can be processed. The disadvantage of the model is the redundancy caused by the values supports of attributes not being set valued. as I said earlier, that every model has its limitations. Every model has its advantages as well as limitations. There are pros and cons. The main disadvantage of this model is redundancy, because we are using the pairs, value pairs, so the values become redundant. So every time we make pair, the previous values always come. So it generate the values which are redundant. Uh, and of course, whenever we have redundant information, it is always difficult to handle it. Another problem is caused by the representation of time as a set of pronouns. Whenever we represent time as a set of pronouns, uh, we missed out some information. So it is very important to define those pronouns in the best possible manner. So here you can see in the McKenzie representation. So once we have the values which are represented in Jan 2001, it is also redundantly used in Jan 2003, and it is also used in the May 2005. So we have those values, and on the left column, these values are indexed by transaction time. So at 0, we have no values which were available in the temporal relation, so it's a null set. And in 2001, we have these values available. So that is the transaction time. In June 2003, we have these values. In May 2005, we have. So every time those values are being repeating. But in this model, the difference is that every temporal relation or the attributes or set value attributes are related to a transaction time. So that is the concept of McKenzie model. Snodgrass model. Snodgrass is one of the pioneers of the temporal databases. I just want to to instruct you people that please go and study this model in detail, because Snodgrass models are being implemented in query languages as well, and those query languages are available. So Snodgrass proposed a temporal query language, and that is called TQL. In 93. Later on, he proposed a new language as well, which we will discuss in the next lecture. So he classified temporal databases into 3 categories, which we have discussed initially in our classes: rollback, historical, and temporal. TQL is a query language for the temporal database employing the valid and transaction time. So he used both the valid and transaction time. He claimed that error correction and retroactive updates could be modeled by the 2 times. He said that it is easily manageable, that whatever the error corrections we have or retroactive updates, when we have, there are 2 types of update: retroactive or proactive. Retroactive or one is that, for example, we update that data and we update it later on. So, or we do it before. So there are 2 possibilities we have: retrospective and retroactive. So a tuple is a tuple time stamping with 4 timestamps, so that a valid time period and transaction time period attached to the tuples. The valid time period represents a valid time period of tuple, whereas so he introduced both the times in the table, and he came out with this concept that we use the interval for valid time, we use the interval for transaction time. So come out with, let's suppose we talk about an entity Salman. So here we have the valid interval as well and the transaction interval, and UC represent here the until changed. It means if the interval is not close. So what you can, he introduced the concept of until change. So he put UC over here, and you can see that we have both the intervals available, valid time and transaction time. It can be equal, it can be different depending on that how you want to represent it. That is the concept of the Snodgrass model. And Snodgrass models are later on introduced also a new query language that is called first is TQL, and then that is called TSQL2, and then there is TSQL4 as well. So we will discuss this later on. That is the representation of various models, and I hope you will understand this. And if you have any queries, please let me know. I will share the content and some papers with you. Thank you.